Welcome to this video about the material derivative, also called substantial derivative or total derivative. The idea is we would like to express the local change of a state variable within a continuum and a control volume. So we have a fluid body B, which is defined by a control volume, and in there we have a fluid particle R, which is already a continuous representation of the real physical particles. Then, based on this definition, we can define the total change of a scalar quantity. It also can be defined for any tensor quantity, the total change. Here we use density. So the total change of the density is a sum of the partial changes. So first of all, it consists of the partial derivative with respect to time and the total change in time, plus the sum of each spatial coordinate change. So the total change of a scalar quantity is a sum of the specific partial changes. And now if we simply divide the right hand side by the dt, we arrive at the material derivative on the left hand side. So we can define the material derivative of the density here, and now on the right hand side, this material derivative consists of, we have a partial change in time plus a partial change in the coordinate direction x1, and we have some substantial change of the coordinate direction with respect to time. We will have a look at this term on the next in the next line, and we will see that we can express this long expression by a simple sum, that we can sum over the spatial coordinates, and we still have this expression here at the end. And the idea is, what is this expression? If we use Einstein's index notation, we can simply write it like this, and this last expression is simply the velocity in the direction. So we can express the material derivative, which is written here, we can express by the partial change with respect to time plus the inner product of the gradient in the velocity direction, in the direction of the gradient. And this is simply the material derivative, and that is useful for a lot of derivations in fluid dynamics. So this is why we need it, and it is a very powerful operator to work on. Thank you for watching this video, and we're happy to see you at the next video.